We'll continue with the rest of the slides for lecture number one. Um, we talked about reinforcements. So the first one we talked about was glass. And the next one, perhaps the most important one, is carbon fiber. And carbon fibers are produced in multiple ways. We The most common one is from a petroleum base, which is polyacrylonitrile, and the next one is pitch-based fibers, which are the bottom barrel of the petroleum base, the remaining constituent of the petroleum fabrication process, or like gasoline and things like that. So whatever is remaining, that part of it is used for um, coal tar pitch and things like that. So whatever is remaining even further than that is pitch, which is the pitch base, and which is used for making carbon fibers. In this process, we use what is called a stabilization. We draw fibers of different diameters, mainly uniform diameters, through a die. There could be in a combined fashion, there could be something like 1,000 fibers that are coming out of this mold, and they are drawn at a specific tension, and they are stabilized by stretching and oxidizing them in air at about 200 degrees centigrade. Then they are go through what is called a carbonization process, where they are stabilized the carbon fibers. Basically, they are like a, a roll of paper, and it is used for making these carbon fibers, which gives you very high strength or very high modulus, or both. And it is stabilized at 1,000 to 1,500 degrees centigrade by eliminating the oxygen, hydrogen, and nitrogen, which results in an increase in strength of the fiber. Then it goes through, typically it could go through what is called a graphitization process, where all the atomic combinations are converted into carbon, and it is done in an inert atmosphere so that the carbon does not burn off. You increase the modulus of these fibers at the expense of strength. So typical tensile strengths are anywhere from 3 to 5 GPa, and a modulus of between 200 to 250 gigapascals, and a density of between 1.7 to 2.1. 2.1 would be if there are impurities and things like that. The ideal density of a carbon fiber is 1.8 grams per cc. The next type of fibers are aramid, which are mainly used for reinforcing plastic resins. These are known under the trade name and sold under the trade name of Kevlar. There are two types of Kevlar fibers. One is Kevlar 29, which is low density, high strength, and used for ropes and cables. And the next one is Kevlar 49, which is used for aerospace and automotive applications. Basically, these are fibers where there are hydrogen bonds bonding the fiber together, and you need extremely good resistance to fatigue, and you need high strength and lightweight. Basically, these could be used for bulletproof vests and things like that. So, how do the mechanical properties compare? So you can see that carbon fibers provide the best combination of modulus and density and strength. So carbon fiber reinforced composites are replacing steel and aluminum in aerospace applications. So you can see that you have carbon fibers which have the best strength and modulus. So this is another figure that shows the comparison of specific strength versus specific modulus. The original extended chain ultra high molecular weight polyethylene fiber introduced by Honeywell's Spectra Performance Materials in 1985, but recently, especially after 9/11, it was more difficult to get these because there was a lot of demand for making bulletproof vests for the law enforcement departments across the country. What are the type of matrix materials that are used in the composites industry? The most common one, because they are the cheapest one, is polyester, and the next one is epoxy resins. They are two of the most important matrix materials. Polyester resins are obviously cheaper than epoxy resins, so you see them being used in many applications such as for boats and auto and aircraft applications and things like that. But epoxy resins are also good because they show good strength, low shrinkage, and also good matrix toughness. So they are commonly used as matrix materials for carbon and aramid fiber composites. So you can see the combination of the tensile strength, modulus, yield strength, etc. for the composites based on polyester and epoxy matrix materials. So what are some of the properties that you can observe in these materials? In fiberglass reinforced polyester resins, which are some of the most common composite materials, higher the weight percent glass, stronger the reinforced plastic is. And if you have a non-parallel alignment, for example, if it is a chopped fiber reinforcement, it reduces strength, because if you have alignment, then it gives you strength in specific directions that you require. In the case of carbon fibers, unless it is absolutely called for, most of the time we try to align the fibers in the specific direction of the loading direction. Because carbon fiber contributes to, it's a rigid fiber composite, and it also provides you with very high strength, while the epoxy matrix contributes to the impact strength itself. In carbon fiber reinforced composite, you can also find materials such as matrix materials such as polyamides or polyphenylene sulfides, especially if you require high temperature exposure to the composite. And carbon fiber composites, as I mentioned to you in the last class, they have exceptional fatigue properties. And most of the time, what we do is we have single sheets of carbon fibers with fibers oriented in specific directions, and they are laminated to meet the strength requirements in the direction of the loading or the direction of the stress. So what do you do? I think we described that in the last class. So what do? You take them, you laminate them, and when you laminate them, you really get very